Hi there, this is Materials Lesson 1. This is Hooke's Law. The objectives are to recall and explain key terminology for changing shape, describe Hooke's Law in words, and explain what elastic limit is. This lesson is very wordy. There's not much maths in it. The next two, however, are heavily mathematical. Let's move on. So, changing shape. Forces can also change the shape of an object. For an object to change shape, at least two forces must be acting. A stretching force puts an object such as a wire or spring under tension, and a squashing force puts an object under compression. So there's some tension, it stretches out, back in, that will be compression. Tension pulling it back out, compression, and so on. Brittle materials such as glass do not change shape easily and break before noticeably stretching, as can be seen in this example. Resilient materials do not break easily at all. So if you see that terminology, resilient, an example will be diamond. Diamond is the most resilient material that we have, according to Google anyway. So elastic materials return to their original shape when the forces on them are removed, as you can see on the right hand side. So stretched out, and when the force is removed, they go back to their original position. Plastic materials retain their new shape. So as an example, let's move on. So what is Hooke's law? Hooke's law states that the extension of a spring is proportional to the force used to stretch the spring. Proportional means that if the force is doubled, then the extension also doubles. And the line of a graph of force against extension will be a straight and go through the origin. Sorry, it will be straight. Let's remove that A, bad English. More like a typo actually, but let's move on. Remember to pause at any point to make any notes. Right, force against extension graph. So it's force in newtons against extension in meters. Straight line. So if you get an elastic material and you apply a force on it, it will extend in this manner. So here's a question for you to have a think of, if you want to try and figure this out. A spring of original length 150 millimeters is extended by 30 millimeters by a force of 4 newtons. Calculate the length of the spring if a force of 12 newtons is applied. So, if a force of 4 newtons will extend a spring by 30 millimeters, 12 newtons divided by 4 is 3 times the amount of force. So it makes sense, if force is proportional to extension, that if we have 3 times the force, we would have 3 times the extension. So the total extension would be 3 times 30 millimeters, which is 90 millimeters of extension. So we have to get the length of the spring. So the full length of the spring would be the original length, the 150 millimeters, plus the 90 millimeters of extension, which gives a grand total of 240 millimeter length. If you got that, well done. Okay, let's move on. So what is the elastic limit? Up to a certain extension, if the force is removed, the spring, or the elastic material, will return to its original length. The spring is said to be behaving elastically. If this critical extension is exceeded, which is known as the elastic limit, the spring will be permanently stretched. Hooke's law is no longer obeyed by the spring if its elastic limit is exceeded. Remember, Hooke's law is that the applied force or the extension is directly proportional to the applied force. So here's an example of a spring. So this first spring is still less than, it's not been stretched past its elastic limit. However, the pore spring on the right hand side has been stretched beyond its elastic limit and is now permanently deformed. So what about a force against extension graph if the elastic limit is exceeded? So it might look something like this. So that point will be the elastic limit. So this left hand side of the graph, if you were doing A level, is called the elastic region. Try and write this in neatly. So the elastic region. On the right hand side, after the elastic limit, so we could say on the right hand side, that's actually called the plastic region or plastic flow region. This bit, it's flowing, so to speak, the line. So plastic region. But it's definitely exceeded the elastic limit. And now, small increases in force will produce a much larger extension. Anyway, let's move on. Just out of interest, it probably won't be on the exam, although you never know. Stretching an elastic band. Might show you this and ask you what it is, or an elastic material, so to speak. Looks something like this. So an elastic band does not obey Hooke's law, as it is not a straight line. Okay, just to finish, let's do a closed exercise. So if you want some comprehensive notes, you can copy this out and fill in the keywords. If not, you can write 1 to 8 and put in the keywords in the right order. If you want to do it without the help words, you can start it now. If you want the help words, I'll put them on now. And then I'll take you through the answer. Or answers. Hooke's law states that when a wire or spring is stretched, the increase in length or extension is proportional to the load force applied. This law is not obeyed if the spring is taken beyond its elastic limit, after which it will become permanently stretched. A rubber band does not obey Hooke's law. A graph illustrating Hooke's law will have a line that is straight and passes through the origin. So hopefully you found that okay. Thanks for watching, and I'll see you at the next one.